So we're told that the ticket prices for evening shows, and I'm going to call that PE, that's the initial, was increased by 10%, meaning the new price would be P sub E. So this is before and then after. And they tell us that, they also tell you something about the number of tickets sold for the evening, which decreases by 5%. So if there were N sub E, again, E representing the evening, this would decrease by 5%, so it would be 95% of the original. And same thing we have for the morning, decreasing the ticket price by 40%, so it would be 60%. And then the number of tickets sold increased by 30%. So NM here would be 1.3 NM. Question is, what was the percent change in total revenue? So initial revenue is NEPE, number of evening tickets sold times the price of evening tickets plus the number of morning tickets sold times the price. So this is your initial revenue. Revenue here would be, again, the price times the number, so 1.1. I'm kind of putting the numbers together. And then 0.6, 1.3, PM, NM. And we're looking for percent change, so we need to find the difference here. I'm actually going to compute this. I've seen these types of questions before. 10, so it's going to be 1.045 PENE. 13 times 6 is 78. I can see some students saying that maybe this is way too much work up front, but I generally find that this kind of comes out, it does help you. So the difference here would be 0.045. Clearly you want to do this algebra quickly. Minus 0.22. You should check my work here. So that's the change over the original times 100 is what I'm looking for. So this could be positive or negative depending on how these numbers turn out. So start with statement 1. The ticket prices of the morning shows and the evening shows were equal. So they're saying this is equal to that. So if you divide each term by that, you'll notice that will disappear and we'll just be left with the numbers here. Times 100. But again, we still don't have a unique value because we don't know anything about how the number of evening and morning tickets relate to each other. So 1 alone is insufficient. 2 gives you the ratio of the number of tickets sold for the morning show to the evening show is 5 to 8. So if I took this and I divided, and this is an operation that's common, if I divided numerator and denominator by n sub m, actually by n sub e. It doesn't really matter, but you'll see n sub e is better because it will become nm. What I'm doing is trying to create that ratio that's given in statement 2. And then we'll have ne plus, no, actually would be 1 because I'm dividing this by ne and this by ne. And then would be PM times NM over NE. You'll see this is what's given to us as 5/8. So for statement 2 alone, we'll have numerical value for that ratio, but I still don't know anything about how the these two prices compare. Actually, you know what? I still have P sub E here. That's not 1. So again, 2 alone is insufficient, but when I combine 1 and 2, since I already did this work, you will see here, if I divide again each one by NE, you will get that ratio. And this is given to us as 5/8. We'll have a unique numerical value, and the 2 statements combined are sufficient. The answer is C.